Good afternoon and welcome to Alarm Corp's webinar for today. My name's Jeff Rushton. Thank you very much for your time attending. It's been quite a while since Alarm Corp has done regular webinars, and towards the end of this one I'll give you some details on all of the future ones that we'll be holding for the remainder of this year. Basically we'll be holding 2 a month, a CCTV related one on the second Tuesday of every month, and an intrusion or access control webinar on every Thursday of every month. But I'll give you more details towards the end of this session. Today's webinar, Seismic Detectors, the Proven Performer. So we'll run through a little bit about seismic detectors, in what applications to use them, what features some of the more common detectors have, and hopefully we can gain a better understanding at the end of this exactly where and when to use a seismic detector. But a little bit of housekeeping before we get started. First of all, for the duration of this webinar, your microphones will be muted. So if at any time you wish to ask a question, please type it in the question bar and hit the send key. Just to ensure that you can both see my screen and hear me, if you wouldn't mind pressing the icon for the raised hand bar, just so I can see that everyone can see what I'm seeing and can hear my voice. Okay, that's excellent. You can unclick that now. And as I've said, at any stage during the course of this webinar, feel free to type in a question and hit submit. And at the end of the short webinar, we'll run through those questions and hopefully be able to supply an answer to you. So the first question is, I suppose, how a seismic works. In its basic scenario, these are the 3 things that a seismic sensor requires. So the sensor is a small device that's obviously attached to the electronics and held on a wall or a safe or something of that nature. And it's looking for an amplitude of the signal. So it's looking for an amount of noise or vibration or frequency. Next is frequency. These are attuned to a particular frequency, and that's all that they look at. So any higher or lower frequencies, this unit or these units typically are unaffected. And with the amplitude and frequency, they have to occur over a given time period in order or before an alarm is generated. If that time period isn't reached, then over time the detector will be less immune and reset. Or if that amplitude or frequency is met again and it's met for the correct criteria, it would then generate an alarm output. I suppose seismics, different people have different effects. I suppose in the general real world, seismic detection is used by authorities around the world to monitor and assess the threat of things like earthquakes or other ground seismic activity like explosions. In our world, in the security world, seismic detection is typically used for all of the points that I've got here. It can be used to detect people and threats to things like pipelines or underground electricity supplies by monitoring the amount of seismic activity around the pipeline and then generating an alarm. Typically though, the most common applications that we see with seismics are to detect things like gross attacks on fixed objects like ATMs, night safes, strong rooms or strong room doors, safes, vaults, vending machines or ticket machines, I've got here walls with a construction of brick or concrete. Basically, any solid construction wall a seismic could be placed on. Also, typical applications are things like chemical or drug stores, or ammunition or gun bunkers. When we talk about seismics for security applications, we can't really go too far or very much past the Siemens seismic detectors. That's one of the products that Alarm Corp sells, and these have got a very, very long history, and as you can see by this graph, they have by far the highest penetration of any detector. That the Siemens detectors equate to over 60% of the seismic detectors sold in the world. Everyone else is in the other 40%. I've been in this business, I don't know how long now, 30 odd years, and I remember when I started as a trainee, the Siemens seismics that we were using as an installer back then was a product called a GM31. It's gone through a few transformations in those last 30 odd years, but ultimately we've got the same sensor, the same basic technology, although it's improved somewhat, to what was available back then. And by far, these particular detectors that I'll be talking about today are used by all of the major banks, all of the ATMs, and all of the high security government areas that require this form of detection. The two seismic detectors in question that we'll be referring to is a product called a GM730 or a GM760. Both of these look much the same. Both of these operate much the same, with just two or three minor differences between them. If we have a look at the GM730, you can see that it's got a range of approximately, or a radius of approximately 4 meters, which equates to about 50 square meters of detection that the detector can cover. The 760, by comparison, has got a radius of 5 meters. It's just slightly larger range, slightly larger amount of area. But both detectors, in fact all the detectors in the range, work quite happily on steel and concrete, like the picture of the ATM there, or concrete or synthetic materials on larger areas that the GM760 can cater for. They quite happily detect all known forms of detection, namely things like water jet, explosions, a thing called an oxygen lance. You'll see a little bit of a video on that shortly. And then drilling, any type of drilling into the device in question. Now, this is the first time that I've tried to do a video over a webinar. It may not come through depending on your connection as a video. It may be a series of still images, but regardless, you'll get a good understanding on, I suppose, the lengths that Siemens go to test their product. And when this starts, we'll just see a few other features that we'll go through a little bit later in any case regarding the how it works. That's a picture now of the sensor, picture of the unit, and we're going to see a guy that looks here like he was out of Lost in Space in a second come on and try and make a hole in a very solid concrete construction wall. Three areas on the right of your screen that we need to look at. There is a blue graph which is showing the level of disturbance on the concrete wall in this case. The purple graph above it really only has, I suppose, two main states. Down the bottom, there's no alarm, and at the top, when it drops off, it's gone into alarm. So you can see, as Mr. Lost in Space is using this oxygen lance on this concrete wall, that the level of disturbance on that blue bar is quite minor, but you'll find that that top bar is slowly increasing over time till the alarm is generated, the alarm output is fired, and then the unit resets and starts that process again. I don't know how well you can see it, but that top bar is going from a secure state, and over time, with the level of activity on that concrete wall, is eventually going into alarm. It's taking about between, let's say, 5 and 7 seconds with the amount of activity that's happening here. This video with him goes quite a while. You can see the length of that rod. If I fast forward it just a little, you can see that the guy's still going. The seismic has gone into alarm every few seconds for the last, X number of minutes while he's been doing this, and obviously he's producing a hole, but that's about as far as he's going. So hopefully you can see that it's just gone into alarm again, and it's raising back up. So in order to detect that, he's just finished, he's given up, he's walked away, and that's pretty much all the damage that he's done to the wall. The fact that these seismics are located obviously on the other side of this concrete wall, I suppose the question gets asked, what about external interference? What about, in this case, if you've got a forklift with a big metal bin that's making lots of actual noise and lots of vibration within, half a metre of that wall? Do you notice both the bars on the right-hand side have not registered any activity whatsoever? So they're very immune to noise outside of the frequency on the wall that it's looking at. I don't know how well that worked, but we'll just move on and show you a little bit more of the features of the GM730. As we've previously said, it has a 4-metre radius for detection. It uses the patented SenseTech biomorph sensor that Siemens have used for many, many years. All the detectors have got digital signal analysis. They all have the ability to have a remote sensitivity control. That is, there's an input on the seismic that allows you, if you put a voltage on it, to reduce the sensitivity of the detector by about 1/5. Typical applications where that could be used is, just think of maybe a bank environment where you've got some ATMs or safes in the bank that have seismics on them, and the cleaners come in at night and vacuum and clean and dust and do whatever the cleaners do. If they bang their vacuum against the ATM or the safe, there's a potential that it may generate an alarm. You could do two things. You could turn off those devices while the cleaners are on site, or you could put the alarm system in a cleaner mode, which means that all of the main levels of detection are still enabled, but in the case of the seismics, their sensitivity is turned down. It's not turned off, it's just turned down to avoid things like cleaners generating an alarm. Also think of maybe an application like, think of a vending machine. You've got a Coke machine and it gets vandalized a lot. If you had a seismic on the vending machine and someone puts in their money and a Coke drops down the bottom, odds are at some stage that will probably generate or trip an alarm on the seismic because of the amount of metal on metal action with the can rolling down and then coming out to be picked up. You could have it that when money is put into the machine, that the level of sensitivity is dropped by, for those few seconds until the can is removed, then the sensitivity goes back to its full range. So there's the ability to do that. The next option, it says here, mounting and functional test with a test transmitter. One of the biggest questions that people ask is how can I test this seismic when it's in operation? Certainly one of the best ways to do it is there's an optional test transmitter. That's a little disc with a couple of wires that gets inserted into some terminals and it sits in its own little location within the seismic detector. Again, by attaching a wire to a terminal that says remote test, you have the ability of putting a voltage on that terminal from your alarm panel and having that test transmitter generate a signal through the safe or the vault or the wall or whatever the device is connected to for a period of time that the seismic will see, and if it's working correctly, generate an alarm and give an alarm output. That way your panel can know it's in test mode and expects to see an alarm on that zone within a period of time, typically 20 or 30 seconds, of which that test is complete. If the panel doesn't receive the alarm in that time, the test has failed and obviously it needs to be looked at. By far that's the best means, certainly it's the way that all banks use these seismics, is to put the panel into test mode and the panel basically does the testing, or the detector does the testing. There's no need for them to do anything with it in order to generate a signal. Certainly these are very easy to install. There's only 2 screws on the inside which would be tapped typically into whatever it's mounted on. The GM730 is also SCEC approved. By itself it's approved to security level 2 or it's approved to security level 4 if it's used with a device called a GM-T4 box. And that's a product you'll see on further slides. The typical applications that we would use a GM730 in would be in a small safe, or an ATM, or a night safe, or a strong room, or on the door of a strong room. GM760 isn't that much different. I'll just highlight the differences. This one has a 5-meter radius, so a slightly larger range. So then typically that would suggest it's for bigger safes or bigger areas. It has the same sensor, same processing, same inputs and outputs. This device also has an alarm memory, an event memory for 100 events. So every time that this device goes into alarm, those last 100 events and the time and date are stored within the detector. So it's a very easy way then to check with the software that I'll be describing shortly to confirm and I suppose marry up that with the event log of either the panel or the control center to confirm that it was actually the device that went into alarm. As well as both of these units can generate an alarm on an extremely low temperature or an extremely high temperature. So in the case of using some of those thermal tools to break into a safe, or potentially using dry ice or some other way of cooling the safe or vault in order to have it crack or otherwise. With the GM730, those temperature ranges are fixed. With the GM760, you can adjust the upper and lower temperature threshold that an alarm will occur. So with the increased range, the applications are still for safes. They can be used on ATMs, but I would suggest you would use the GM730. Strong room doors, modular, and lightweight synthetic material. So typically where you have a larger safe or a larger vault or a larger wall where you would like to use less of these and to cover more area, the GM760 is perfectly suitable. The GM-T4 box is a box that Alarm Corp developed in order to meet the highest security level of any electronic security product. This box, when used with a GM730, meets security level 4, which is again the highest level that ASIO or T4 has. It gives you the advantage that the box is tamper resistant. There's plenty of space in it for both any cabling that you have or in fact anyone's high security end-of-line module. And the cable entry has got a partition in it so to stop any possibility of tampering with either the cable or the connections. For any SCEC or government work, Alarm Corp would definitely recommend you use the GM730 with this box. Just the features side by side of the two units. I'll only highlight the more important ones here. You know, we've discussed the increase in range with the 760. Things like shock settings, polarity of the inputs, polarity or whether it's normally open or normally closed on the output. They're all done by, it's got their PC tool. It's done by a bit of software and a cable that I'll talk about in a couple of slides. As the units come, they just come with 2 dip switches that are set in the case of the GM730. The settings say that they're set for steel high, steel low, concrete, and user mode. Typically these are used in things like ATMs and vending machines. So all they do is set the dip switches for steel low, and then it automatically sets the device for the required sensitivity and range. You can see that the GM760, on the other hand, although it can still operate in an ATM, the default switch settings are concrete, steel, and lightweight synthetic material. That steel setting, also the concrete setting, is a 5-meter setting, so it automatically comes at its highest sensitivity when located or mounted on a concrete or a brick wall. You can use the software to adjust the 760 to the same settings as the 730, but it does mean having a laptop, some software, and a cable. They both have digital filters that can be enabled to eliminate or to mask various noise on ATMs. There's a number of peculiarities with ATMs that potentially could set off a seismic. By enabling the digital filters on these, it will exclude any of that common repetitive noise that an ATM has. They both have the option for a thing called an anti-drill shield. Basically, it's a cover that's tampered that goes over a keyhole in a safe so that you both need to disable your alarm system and then move this anti-drill shield up in order to either put your key in the safe or to use the combination to open it. They are very well tampered, both on the back and the front. There's an LED indicator on them to indicate when the unit is in alarm. And there is a test point that you could stick a multimeter in if you didn't have a laptop and the software in order to test the level of noise that the unit is experiencing. These seismics are used all over the world and got various approval ratings. Certainly they're fully approved for use here, as well as I've said now a couple of times that the GM730 is a SCECA endorsed product as well. The GMSW7, we call it the Sense Tool software. It's a small software package, comes on a disk or you can download it from our website. Is used in conjunction with a cable that you would purchase from us as part of this kit that has a serial connection at one end and what looks to be a mini USB connection at the other. It's not, but it's very similar. That end plugs directly into the connector on the seismics, and we can use this software to either change or adjust any of the settings that are possible. Hopefully you can see by the look of that screen that you can see typically the installer would pick the application that the product is mounted on. You can see there with this particular seismic you've got the ability of a lightweight synthetic at a 2 meter radius, at 1.5 meter radius, if it's mounted on a concrete wall with and you want 5 meter radius coverage or a 4 meter radius coverage or a 2.5 meter radius coverage, and both steel at 2 meters or at 1.5 meters. Then in conjunction with the application that the unit is mounted on, you can then pick the shock sensitivity, which is the gross attack, whether it's a drill or a hammer or a sledgehammer or a ram raid, an attack that has an immediate requirement for alarm. We can adjust the sensitivity on that from high, medium or low. They're the only two options really that would set the sensitivity and range of the unit. The other settings on the right hand side relate to the type of detector that's connected, whether the test inputs are active high or low, whether you're turning on the temperature surveillance, and in the case of this detector then we can pick the higher or lower temperature. By default, you may be able to see on here, it says that any temperature above 70 degrees Celsius or any temperature below minus 40 degrees Celsius would generate an alarm if we had that function turned on. There's a couple of other tabs you can use. I don't have a screenshot of that in this presentation, but basically we can go to the Analyze tab that's at the top there, and we can watch in real time those graphs that we saw in the video to determine the amount of activity and then the level of activity that was required in order to generate an alarm. Typically the way that I would describe the way that a seismic works would be similar to how I describe a way that a capacitor works, in the sense that, if you put a small voltage on a capacitor, it will charge and charge and charge, and when it's full, in this case of the seismic, that it's gone into alarm, you take that voltage off, that capacitor will discharge over time rather slowly. And if you put the voltage back on, it would begin charging from where its current capacity is. The seismic works in exactly the same way, in that you could have a small amount of activity, on that safe, on that vault, on that ATM. But as long as that small amount of activity occurs for a reasonable amount of time, even if you stop that activity for a number of seconds and start it again, the seismic will still be where it left off, so it will continue. In the case of anything other than a gross attack, a seismic doesn't need to generate an alarm immediately. You're not going to get into an ATM by, drilling through the front of it, within a few seconds, or using that oxygen lance, or using an oxyacetylene torch to cut through it. Those things are going to take many minutes, and the detector would pick that up within 15 or 20 seconds, which is its limit. But if it was blown up, hit by a car, or hit by a sledgehammer, that shock sensor would generate an alarm immediately and activate the relay. I figure that might be a good introduction to the Siemens seismics at the moment. Certainly, if you would like some more information, the best place to find that immediately is via our website. Both brochures and data sheets can be found there. You can also subscribe to our newsletter to receive information or invitations to future webinars. You could also register at our website and you would get full user access, which means that you would get now all of the software that's available for our products, any technical manuals, installation manuals, operating manuals that we have, as well as the ability to order and see pricing on our website as well. Or, of course, you could contact us. You could contact myself or Diane or Richard in New South Wales, or Stephen Dinger in Victoria, South Australia and WA. As I said at the beginning of this webinar, we'll be having a lot of regular webinars through the course of this year. Every third Thursday of every month, there will be a security-related webinar. These are the ones upcoming or coming up for next month and beyond. You can wait if you want to join along to these. You can wait for your invite. It will come through the mail, or you can happily go to our website under the resources section, and you can register now for as many as you want, and it will give you a reminder just before that the webinar is due. We will be having monthly CCTV webinars at the moment. They will occur on every second Tuesday of the month from next month onwards. I don't have a full schedule of that. It will be on our website by the weekend, and the same applies. Once they're up there, you can quite happily register to be reminded when those approach. As I've said in the beginning, if you do have any questions, now would be a great time to ask them. Just see what we've got here. Okay. One of the first questions, someone's asked regarding the GM 760 as to whether that is SCEC endorsed or not. Short answer is no. If you have a T4 government SCEC requirement, then you have to use the GM 730. Ultimately, both detectors are the same in the way that they work. It really is more a marketing exercise rather than a technical limitation as to why the GM 760 isn't on the approved list. That ultimately doesn't affect installers or the end user at all. The GM 730 is considerably cheaper than the GM 760, and really its only downfall is it's got a 1 meter less radius than the GM 760. But certainly, yes, if you have a SCEC requirement, it needs to be a GM 730, and I would highly recommend that it's installed in a GM T4 box on all your applications. For a number of reasons, the box isn't overly expensive, and it will allow you to fit your high security end of line module in Without that box, you're going to have to come up with your own tampered, secure box to mount and have that mounted directly next to the seismic in order for it to be approved. So in this case, you can just stick the GMT4 box on the wall, put the seismic in, run your cable to it via conduit or through the wall into the back of the box, and you've got now a fully secure, approved installation. If you've got any more questions, please keep them coming. Someone has also asked, can we view this webinar at a later date? Absolutely. In the case of the people that are here today and have viewed all of it or viewed part of it, you will receive an email tomorrow with a link directly to the recorded webinar. That link will also be on the resources section of our webpage. If for whatever reason, and you won't be hearing it now, but if you miss the webinar today, you will receive an email automatically in about an hour's time saying, sorry, that you're unable to attend, and there will be a link to view the recorded webinar as well. So regardless of whether you're here or not, you will have the ability of replaying my dulcet tones at any time. If anyone has any more questions, someone's asked a question that I'll inadvertently answer regarding how many seismics are sold in Australia each year. Security companies are very coy when it comes to numbers. So it's very difficult to get definitive numbers of the whole market. I obviously can only speak from Alarm Corp's position, and without divulging that neither, I can say we're talking many, many thousands of units a year. These detectors, I suppose have a niche market in many ways, but it's funny that when you open your eyes to solving end users' problems, you'll be surprised in how many applications these sorts of products can fit into. Certainly, without question, our main market is the financial market as well as the high security market, as the GM730 is the only product of its type, in fact of any type of that nature, that is approved. The only other seismic type vibration product that I'm aware of as an endorsed product is also a Siemens product that we sell, and it's a vibration switch called an ES400. They're the only two products that I'm aware of that you can mount on a wall or an area or a device that will definitely detect an alarm on a gross attack or a ram raid or some other way of accessing a concrete, brick or steel enclosure. I might just answer this last question as well. Someone else has asked, what frequency do these seismics detect? All of the Siemens seismics are set up to detect only frequencies at 16 kilohertz. So that's a relatively low frequency, and it's very defined. That is, it is immune to frequencies lower or higher to that, and that makes the device very stable, extremely, it's 100% proven to go into alarm on any of these forms of attack that we've talked about. And it really does really reduce the possibility of this device false alarming under certain conditions. The only conditions that I would say that you would need to be at least semi-wary of would be if you've mounted seismics on a large, let's call it a concrete structure, and there are other machineries, devices, equipment that is located above or below the building that generates a lot of noise and frequency. It might be a big power plant. It could be, I don't know, all sorts of different types of machinery that are connected directly to the concrete structure that the seismics are mounted on. Typically, the way to avoid any of that is to have isolation between any of those machines, and that's pretty normal on just about any site, where there'll be isolation between the machinery generating that noise and then the concrete structure that it's mounted on. That's about the only application or area that I would say that you're likely to even remotely have issues with a seismic detector. But all of those details, all of that history can be looked at with the software and the cable. So it's very easy to view in real time the effect that that noise has on a seismic that's already been installed. If there are no further questions, I'd certainly like to thank you very much for your time today. Certainly we appreciate the time that you've taken out of your day. I hope that the information provided was interesting to you, and certainly look forward to seeing you on future webinars. So enjoy the rest of your day. Goodbye.